Thank you. Thank you very much. Very excited to be here. So first, thanks to everybody who made it possible. So that was awesome. I do come from Redmond, which is on the other side of Seattle, though I live in the mountains of Washington. This is my gaggle of family. I have a pretty big family. I have 4 children now. I didn't start that way, but thought it would be 1, and then here you are. I also have my dad, who's 70, who lives with me. I have little toddlers. My oldest son, he just turned 14, which is crazy to say out loud, but he has Down syndrome, and yesterday was World Down Syndrome Day, and it really has changed the way I write software. I am now much more interested in making sure the world can use software, the world can access software, and the world is not just those of us that have the unique position of being able to work on small devices like our phones or even our screens on our computers. There's many, many people. I work with engineers that have that are quadriplegics, that cannot use their hands, that write software with their mind, with their voice. And so one of the things I want to share with you today is how very important it is to start thinking, yes, it's going to be awesome and cool to build with voice technology. It's easier than ever before to do these things, but there's a bigger reason why it's important. There are millions of people who cannot access the software that myself, I've spent years and years building, because we just didn't really have the technology to make it accessible. So by the end of this talk, hopefully you'll have some ideas about how you can do just a little, something a little bit different, but expand the accessibility of the software you might create one day, or maybe that you're working on right now. So I always like to start with a video. I'm gonna live stream from YouTube, so you know, like, think good thoughts for me right now. So let's just take a moment and listen to it. It's only about a minute.
Today, right now, you have more power at your fingertips than entire generations that came before you. Think about that. That's what technology really is. It's possibility, it's adaptability, it's capability. But in the end, it's only a tool. What's a hammer without a person who swings it? It's not about what technology can do, it's about what you can do with it. You're the voice, and it's the microphone. When you're the artist, it's the paintbrush. We are living in the future we always dreamed of. We have mixed reality that changes how we see the world, and AI empowering us to change the world we see. You have more power at your fingertips than entire generations that came before you. So here's the question. What will you do with it?
Amazing. Every time I watch this, I've seen it hundreds of times, and I'm always like, let's go. We got to go build something amazing. And then YouTube, like, be careful what comes up. Don't look. You never know. It's very dangerous. Let me close it right away. I'll come back to that later. But this video actually was launched. It was a whole campaign around AI for all, AI for everyone. It's the reason I left. I should give you a little history about me. If you don't know, there's this cool app. I don't know if you've heard of it. Maybe you have. If not, I will introduce it to you now. I hope you've heard of it. It's called LinkedIn. Have you heard of it? Okay, it's a little bit of a joke. I hope you've heard of it. If not, we need to improve our marketing. But there's an app out there. It's really great for your career or future career. I am relatively well connected in the space of AI and voice conversation. I now consider you all my very dear friends. So what you could do if you have a phone and it happens to have LinkedIn, and you might not, you can find me on here. You can connect with me. You don't have to write me a note. We're good now. You can. It would be great to hear from you. But you can also, if you had it now, there's this cool little feature that allows you to use Bluetooth technology, and actually right this second, we could be connected. You'd show up on my little screen. I'd say, invite, invite, invite. And we'd all be friends. So it's one mechanism that you should leverage because, like I said, you don't know today, but oftentimes people that I speak with, within weeks, months, or years, I end up being able to connect them with someone that can either help their career or help their startup or get them funding. Like, you never know. It's a small world. This is a very unique opportunity that I'm here with you today. So I just want to extend that and you are more than welcome to connect with me in that way. Thank you. You're awesome. If I had a sticker, I would give it to you. So thank you. So we have one other thing that I like to do to kick it off is something that is also kind of, you're never supposed to do this at conferences or on stage. But I'm going to do it anyway, so bear with me. I'm just going to read to you a quote that I think will set the stage for what I'm going to do for the rest of the talk. So it's actually an important quote that I've heard all the CEOs I've ever worked for have quoted this to me at some point in my career. What is success? To laugh often and much, to win the respect of intelligent people and the affection of children, to earn the appreciation of honest critics and endure the betrayal of false friends, to appreciate the beauty, to find the best in others, to leave the world a bit better, whether by a healthy child or a garden patch or a redeemed social condition. To know that just one life has breathed easier because you have lived, this is to have succeeded. Now, this was originally written, well, I should say, it was made popular by Ralph Waldo Emerson, an American poet, laureate, metaphysician, very popular guy. But turns out he actually borrowed it from a woman, also a poet, who just didn't make it sound as cool. Same stuff, just slightly different words. So he made it popular. Bessie Anderson deserves some props because she actually was the one who created it. But the reason this quote is interesting is because in the spirit of AI, in the spirit of that video that you just saw, we have more power to do things that took decades to do before today. Our generations of engineers before us had to spend long hours, days, years, building the things that we can now use as a web service. So this is like a super easy test. Do you know what a web service is? Raise your hand if you know what a web service is. Please, one. Okay. I know you're a room of people who don't raise hands. I get that. Okay. So thank you for the 4 of you that admitted to knowing what that is. But a web service is basically the easiest way to write software, right? If I could just string together a bunch of other people's code to make something happen, it's the quickest way to build an app. And web services are your way. If you're going to build something, you'd want to create it as a web service. So someone could just call a URL and get access to all your code in a single call. I'm going to show you examples of it in case you aren't seriously not familiar with web services, in which case I would put that number 1 on your list of things to kind of figure out. Conversational AI will be very complex compared to a web service. So we'll want to look at that. But we have more power than ever. We have more technology at our fingertips than ever before. You can build things that we could never build in the past. However, there's another quote. I hope those of you who are familiar with this genre will help me out. But with great power comes, anyone? Oh, thank goodness. Okay, great responsibility. It's a global thing. Spider-Man, Emerson, all you need. Life lessons, people. This is it. It's the good stuff. But with great power comes great responsibility. Today, if you are in a computer science field, I would highly encourage you to be taking as many ethics classes as you can. Ethics in AI is something that everyone knows we need. Not a whole lot of people are actually doing. But Microsoft is, and Amazon for that matter, we're very aware of the technologies that we're building. Little secret. So I started off in Alexa. It was one of the first day, right? They came to a whole bunch of solution architects, which are basically people who write software for fun and talk about it, and help customers. So I get I get to the office and they're like, we're doing this new cool thing. Now, literally the day before, we had just sunset a product called the Amazon Fire Phone. Anyone know it? It was a dismal failure. Everyone on the team got fired. It was horrible. And the next day, to the same people, they're like, we're going to do this new thing. So it was like being on the line where everyone's like, who volunteers? And everybody stood back one step, and I was like, what are we doing? Right? And they're like, Noelle, okay, great, thanks for volunteering. So I was employee 2 on the Alexa skills team and started building skills for a platform. So today, how many of you know what Alexa is? Another easy test, right? Okay, there's a few of you. I should more ask you who doesn't and see who's willing to raise. Okay, but you should go find out a little bit about it if you watch any TV or anyway, if you've been around. But Alexa is this voice assistant. But 5 years ago, I started talking about it, and people looked at me like I was crazy. Like they were like, that sounds amazing, but it's science fiction. And I had to go through this 5 year of time span where now at least like half the room admitted to knowing what it is. But when I started, no one did. And everyone was kind of worried it would be another big failure. So imagine that. Right now, there are 66 million people in the world that claim to own an Alexa device. There are tens of millions that have access to Alexa through the devices in their home or in their car or in their office. There are actually billions of people if you count the Cortana-Alexa friendship that recently blossomed, right? So everyone who has a laptop with Windows 10 on it, 2.8 billion people or something like that, have the ability to launch Alexa. So imagine if you built an application that you could use your voice to talk to. That's a lot of people. You need a very small percentage of that number to use your software to have a very large customer base. So this is much bigger than we ever thought it would be. And what I ended up finding out at my time at Alexa, I built about 40 commercial skills for Alexa. 5 of them are very popular. As a matter of fact, one of them is getting featured in a commercial in just a couple weeks. So I built the Mindfulness Skill. It's literally the skill on the platform, the only one where you can say, open mindfulness, and that's mine. And it was back in the day when they didn't really realize the impact of single word invocations in NLU, but I got through. I also built one called Daily Affirmation, hugely popular. I have over 1 million unique users of an extremely simple skill where you just say, what's my affirmation? And it tells you, you look pretty today, something like that, right? We all need it. I'll tell you something funny, the statistics on my usage, people, majority of people call my skill at 8 a.m. and 12 a.m., like European time, which made me realize that most people need love, like in the morning, so be nice to your friends right around 8 o'clock, and at lunchtime. So these are unique opportunities where you could change the world, because people are like, they're so hungry they're going to Alexa for like comfort. So be nice to your friends, if I could do nothing. But we have a huge amount of technology beyond, like Alexa's literally a box. It's upstairs. But for those of you, how many of you are registered for the workshop this afternoon? A few of you? Oh, you're missing out. It's too bad. But we're going to build some skills. We're actually going to build a couple skills within an hour. It's going to be amazing. But then we're also going to integrate some other AI services with it. And what you'll notice when you get into this technology is there's a lot to it. But the most important thing to realize is every single piece of functionality that Alexa is handwritten by someone. It is not magic. It's magic to the users. So like my dad, every time he launches a skill of mine and something magical happens, like the lights turn on, his face is like, oh, that's amazing, right? And I'm like, well, it's 800 lines of code, right? That's like when that sensor goes off, like when you hear this word, turn it into this piece of code and then call this function. It's not magic. It's not like artificial intelligence is exactly what it sounds like. It's artificially intelligent because a dev, like some of you, wrote the code to make it happen. We call it weak AI. So the early days of Alexa was all weak AI. It was AI that was like literally business logic handwritten by a dev that said, if you say this, go do that. Very direct line of communication. Now, we eventually, like I was at Alexa for 4 years going, that's awesome, but gosh, there must be more than just NLU. Like there must be more than just natural language. And so I finally got to a point where I was able to uncover this really cool capability like, oh, there are other AI services that I can integrate into Alexa to create even more engaging skills. So let me talk to you a little bit about those. And this is kind of broad reaching, even though it's under the umbrella of Microsoft. Speaking of umbrella, I'm going to do a little charades activity with you. See where your mind is at. Uh-oh. We'll see if it works. It's not awesome. Let's try another one. It's invisible. All right. That's a little bit better. All right. Anyone? No? Okay. So most people at this point are like, oh, maybe it's a cupcake. No. So yes, it's an umbrella, right? So this is good old-fashioned Microsoft in artificial intelligence, and really, it's just AI in general. It is a huge umbrella statement. It is not a thing. You cannot download it. You can't buy it. You can't wrap your arms around it. It's an idea. But in this idea, there are 3 different areas, the way we see the world, specifically at Microsoft and even at Amazon Alexa, is that there's this side of it, which is this first side, called pre-built AI. So imagine, if you will, and I'll break down AI for you even more for those of you not familiar with the term, but artificial intelligence, specifically machine learning, is the ability to build algorithms that are able to make predictions that help you make decisions in code. And so the reality is that without predictions, you'd have to create a bunch of use cases in your code, a bunch of switch statements to accommodate every single thing someone might say. You couldn't make any presumptions, you couldn't guess, because you had no idea. Machine learning gives you the ability to make a guess, get a percentage of confidence based on data, like I'm 90% sure, 80% sure, and then based on that, at least make an educated guess. It's still guessing though, which is why AI is called research, because it fails more than it succeeds. But imagine if you could, like, go back, let's say Microsoft's been working on their natural language engine for 25 years. Wouldn't it be amazing if you could take Microsoft's AI machine learning algorithms, take all of, so this is what we call a machine learning model, take all of the models and all of Microsoft's data that they have curated specifically to train those models. Wouldn't it be interesting if you could take those models and those data and that data and like build software on it? I'm going to show you exactly how to do that. This is things like facial recognition. Let's see, the ability to analyze images for text, OCR, right? Standard stuff. You don't need anything special to be able to figure out font on an image on Instagram. But it'd be cool to be able to do it in your app without, as a dev, needing to know the model that was needed to do that. So all of these are exposed as what we call web services, which means that all you need is a URL, you pass in an image, and out comes that confidence number that says, I'm pretty sure there's a bottle in that picture. I'm pretty sure there's a person and a dog, and that dog is a Labrador. I'm 90% sure. And you, as a developer, would go, if it's 90%, go with it. If it's 60%, let's pretend like we don't know, right? Just depends on your industry how important those percentages are, right? If I'm building an app that determines what dog you look like, yes, there's an app for that. Like, you don't want to know what dog it thinks I look like. Maybe you could guess. But there's this app for that. It's like, what dog are you or whatever. It uses AI to do facial recognition and map it confidence-wise to a bunch of dog species. But in that case, if I get a 60% hit, it's still funny. It's still entertaining. The app still wins if I'm 60% sure. However, if I'm building a medical application, right? If I'm building something that helps with diagnoses or something that helps doctors whittle down what you're diagnosed with, I probably don't want to be 60% sure you've got something before I tell you that you have it, right? So medical terms are a little bit more restrictive. So then we shoot more for the 98% or 92% of level of confidence. And even then, these are all confidence intervals, meaning that they are all numbers. So at no point are you going to get, and nor should you trust, a machine that says I'm 100% confident this is the case. Why? Because we train it on data. And that data comes from humans, and guess what? Humans are flawed, bad. It's not good. So we don't make good data, and therefore our models are inherently flawed. So as a researcher, as someone in AI research, which is the organization I joined at Microsoft, my job is to always be on the lookout for models that are too good, because it indicates a problem with your data. So there's these pre-built AIs, right? Microsoft models, Microsoft data. I could use them as web services. I can solve a bunch of problems. I'll show you what those problems are in a sec. Then there's the other side. Some of you might be intrigued by this. What we call code first, meaning that you're going to build the model from scratch. This is where lots of time and effort is used because you have to get good data. Flawed people, good data, hard problem. Right? So get good data, then you have to take that good data and pick an algorithm. There are hundreds of algorithms. and you have to somehow figure out which one to pick. You never pick the right one the first time. Sometimes it takes you 6 or 7 times. Each iteration is like 6 to 10 months long. It could be mind-numbingly painful. So, you basically are building your own model. I'll call it yours, right? Your model. You have to come up with your data. However, you solve problems that have never been solved before, right? You change the world. You build the Facebook of the world, or you build the Google search engine, right? Those are models that were never built. Someone had to build those models. Someone had to test out the algorithms. Someone has to constantly tune those algorithms. This is a code-first model. They are both part of the same solution, just different sides, right? So where we sit, or the reason I came to Microsoft, is that I was really happy with the Alexa side, which was me using NLU, Natural Language as a Service, but I wanted more than that. I wanted to customize it. If you say to Alexa a word that is not in her dictionary, she will say, I have no idea what you're talking about. Not in those words, right? I don't know that one. Try again later, or something like that. Or she'll just beep out. She'll go beep, beep, and you're like, oh. Like, did you hear me? And no. So there are words that she will not understand, or it will not understand. So wouldn't it be great if I could take the model development work, the algorithm selection, the tuning of the model, all of that, take that from a company on the pre-built AI side, combine it with my very specific data, the words that I speak, and then create what we call custom AI. So for those of you super interested in this space, this is what we're going to focus on this afternoon. There is 2 models today that support this. It's very rare because companies get paid to do this. This says we're going to give you the model, and we're going to hope you pay us eventually. It's a very trustworthy model. But it's called Custom Vision, and I'm going to show this to you right now, .ai, and Custom Speech. So what happens, and those are websites. You can go out and take a look at them. I'll show them to you right now. But basically what happens is that this side of the world is super easy, but eventually you're going to run into a block where you can't go any further. The data provided by the company, Microsoft in this case, won't get you the right answer, won't get you the right confidence. So you need to infuse it with your data. And there's only 2 models today that support that, but Microsoft is building all of their models to have this custom layer. Other companies don't necessarily find value in giving away models for free. So they're not as interested in doing that work. But I think it opens up the world. I mean, there's so much now more that you can do. So I do want to make sure you recognize that all of these things have people behind them. Each one of these boxes has like 1,000 people working on the products. But CPUs, FPGAs, there was a guy at the lightning talk. Did you guys hear him last night? Anyway, lightning talks, you should go tonight. They were awesome yesterday. The ones that were in English that I could understand was awesome. But he was talking about FPGAs and like processing speed. So there's a team that has to work on how long it's going to take you to do the work of just processing the data. So to give you a very brief, quick example, we had a company 2 years ago. Their engineers were looking at images of silicon, like hardware, and going, yeah, that looks good, bad, good, bad, with their eyes. It took them 3 seconds per image to determine whether or not the image was a good picture or a bad picture, which then escalated them to the next step of actually doing something about it. Half of their day, engineers, half of their day was spent physically analyzing images with their eyes to determine whether or not they were worth looking at further. What? 2 years ago, like this is like in the 2000s. Anyway, crazy. They didn't complain. Such good engineers. People are so nice. They didn't complain. But what we did was we introduced, well, what if we could get a CPU involved and start maybe getting a CPU to help out with some of that imaging, adding on custom vision to do some of that work. They went from doing 3 seconds per image to doing 6 images a second. To an engineer, they're like, hallelujah, like, this is amazing. I'm so excited. They were ecstatic. But it's 6 images a second. Still, we've got to be able to do better. So enter GPUs. GPUs are just a faster, better, faster, stronger. Now this is a simplified version. There's a lot of cool, really important depth that you should go to if you're interested in the hardware side of things. But it's important for you to understand like why we're going so fast and why democratized AI is possible is because this processing can happen so quickly. So GPUs were introduced and we got into the double digits. Now we're like 60, 80 images a second. What? That's like compared to one image, 3 seconds, 2 years ago, like they're flying. They used to walk into the office, press a button, and it would take like 15 minutes for the process to complete. Now they go in and it takes them about 5 minutes. But then they found for a very specific use case, they have a very specific thing they're looking for. They were able to leverage a new technology. It's called Project Brainwave at Microsoft, but we leverage FPGAs. They're now doing 800 images a second. So guess what? They have way more opportunity to fix broken things because they can process more images, which gives them better predictions. Everything goes better and faster and stronger. So it's important to realize that there are people working on this all across all major tech companies, and it's not something you technically need to worry about, but you should know that it happens. If you are super interested in the code first side, there's lots of technology here that is not Microsoft specific. Like Google has TensorFlow, awesome, you should learn it, I like it. If you do nothing in your career, AI is like here to stay. It's not, it may seem like a fad, but it's like a 20-year fad and we're in year 2. So I would get on board. The first thing I would encourage you to do is build your A model from scratch. You can do it for free through any number of online classes. Connect with me on LinkedIn. I will send you a list. But learn to build a model from scratch. The reason is 5 years from now, people won't be building models too much anymore. Very specialized services will. Most people will be on pre-built models. But if you don't know how it's built, you won't know what to do when it's broken. And that is the worst place to be in as a dev. Like to be looking at code you didn't write and trying to figure out why it's not working. So learning to build a model will educate you on kind of those inner workings. So we had to figure out a way, though, to leverage these services. So oftentimes people are like, well, what are all the things I can do? So maybe it's an animation. Oh, they're there. So these are all, and I apologize for you guys way up there in the nosebleed section, but we have lots of features that are capable through web services. These are all the things you can do just by calling a single URL. You pass in an image, a video, text, whatever, some very simple piece of data, and it will output metadata and a bunch of other things. Let me show you what I mean. So you'll get this deck. I hope Jacob will make that happen somehow. But let me really quickly just show you an example, which will hopefully bring this to life. Oh, goodness. There we go. So anyway, you can go to this link. This is also in the deck when you get it. This is also on, if you know of a website called slideshare.net, you can just look for my name. This deck is there too. So aka.ms/cognitive services. So I just want to show you there's a way to test out all these features right inside of a browser. I'm going to show you one on the computer vision side, and then I'm going to finish with a speech services example. So you can see here, I'm just going to go in and show you. We have the ability to analyze images. So let's say you're building a mobile app or a web app. It's way better to tell a user to take a picture of something rather than have them describe it to you, especially like in retail or car accidents or insurance, right? I don't want to be like, my VIN number is, do you have VIN numbers here for cars, right? Like it's like ridiculously long character that I'm almost positive I will get wrong when I say it out loud. So this gives us the ability to leverage computers to analyze those images for content. So you can see here, right, I could go to any of these. Here's a building. You'll see the actual description. It'll say, oh, I'm pretty sure it's a building. I'm 73% confident, right? Can you see that? Right, this is what you get. You pass in an image and you get all this stuff. It looks like a lot. But if you read it, it's actually pretty, like I think there's sky involved. 99% confident there's sky in there. All right. Right? I can go over here, and it'll say outdoors, people, 85% sure these are people. Okay, I mean, I get it. Computers don't want to be like all in. I get it. Like, let's see, roller skating. 94% sure he's roller skating. I see why. 4 wheels, right? Like, what data was it trained on? If a roller skate equals 4 wheels and like a platform you're standing on, okay, I get it. If it doesn't say what you want, anyone have an idea of what we'd have to do to make it say what we want? I'll give you a second. You'd have to, yes, I think someone said it. You have to give it more data. You have to give it the data that it would need to make a better decision. So if it's thinking this is roller skating because it's never seen a skateboard before, I would have to give it a bunch of skateboards, maybe 5 skateboard pictures, and say that's not it. And just by telling it that's not it, it now will declassify this as a right answer, right? So you have to train it that way. I had a very specific question, which was, you might know this, but there is 2 characters in Disney that I always get confused. They're chipmunks. They're called Chip and Dale. You might not know them, so I will introduce you to them, maybe, if my button will work. Oh, it's thinking. I've overclicked now. Oh, boy. Let's see what happens. Oh, submit. For goodness sakes. This is what happens when you're like exposition showing what you're doing. Ugh. All right, so I have in here somewhere some pictures of these characters. Let's see if I can find them. There we go. There we go. Oh, goodness, that's not it. Back. Won't take too long. I think I have it in images. There we go. So I had this question. What's the difference between Chip and Dale? Anyone know the difference, by the way? See, you do? One person? Nobody? Oh. See, I will help you. And for the rest of your life, you'll be like, I learned that from Microsoft. Okay. They will be so proud. So I'm going to say, open this up. I have no idea what picture this is because I didn't have it in thumbnail. Okay, that's Chip and Dale. You recognize them? All right. So you can go over here and look. It says stuffed, yes, animal, mascot, panda. Right, so we're getting a little far here. A toy, okay. Description, oh, these are my favorite. Brown park board, holding, wearing white tree, riding dog, okay. So maybe I want to educate the model a little bit on this. So let's talk about, again, no coding experience required. I want to do, this is the pre-built model that's giving me some data. Maybe it's enough for me to go stuffed, 90% sure, okay, it's a whatever. Maybe I can make decisions on that. In my case, I can't because I need to know the difference between the two. So I'm going to use custom AI, hopefully. Custom vision, right, to tell the difference. So you'll see here, let me sign in really quick. Hopefully, it won't be too painful. And what I did was I created a custom model. Yes, thank you. And all that means is that I loaded a bunch of data on top of the model you just saw, right? So I'm literally here, where I took Microsoft's vision model, and now I'm going to infuse it with more data, which means I'm not starting from scratch. I'm not building the model and adding brand new data. I'm literally training on top. It's called transfer learning. I'm training on top of the model, right? So I have to go in and find a bunch of pictures of Chip and Dale. I just went on the internet. These are not copyright. Don't ask Disney if I was allowed to do this, because I probably wasn't. Darn, this is going to be on YouTube. Just kidding. So I go in. You can see here, I load up a picture, a bunch of them, and I literally draw a square around the thing I want it to identify. In this case, here's the kicker. Chip, the way you tell the difference, is Chip has a chocolate chip brown nose, and Dale is the other one. And the reason I say it like that is my model could not tell, was very bad at telling Dale, right? Why? Because that brownish, reddish color, it changed. In all the pictures, it's slightly a different color. Black is always black. But like brown, in some lights looked more brown, some lights it looked more red, some lights it looked orange, and it couldn't tell, so it wasn't as confident. But if I knew I had Chip, I could choose Dale, right, automatically, because there's only 2, thank goodness. So I went in, I literally drew a box, said Dale, drew a box, said Chip. In this case, this is an example where you'll notice if you look at their faces, I probably could have done their whole face, because their eyebrows are different, their eyelashes are different. So I could have done the whole face, but I didn't know that at the time. Now I know a lot about Chip and Dale's face. But at the time, all I knew was their nose. So I went through, and you can see I did this for, all you need is 15 images, which is ridiculous. People used to have trained models on millions of pieces of data. I needed 15 images for it to make an accurate prediction. So I went in to all of these 15 images. I think I ended up using 21, and I'll tell you why in just a second. But I trained it all. I went in, boxed it all up. I hit train. It then generated for me some performance data. You can see all my iterations over here. You guys remember what I said at the beginning? What happens when your models say 100% positive? Well, you'll notice here, like it's like, I'm 100% positive that it's Chip and Dale. And the reality is when I went into it and tested it, it was saying Chip was Dale and Dale was Chip. It was 100% positive, though, that those decisions were right, which is this scary thing for a model. I'm 100% sure this is wrong. Wait. So that's why you have to be really careful about where your precision numbers are. So I won't get into all the machine learning here. We could certainly talk about it later. But this gives you somewhat of an idea. I was not looking for the 100%. I was looking more for like 80, 90%. I got here and I was like, oh, this is good. So this gave me an idea that my model was performing accurately. And then I went in and I said, well, let me do a quick test against this model. So I go out and I grab a file, an image. I try to identify one that's not in the data set so that it's testing all new. Oh, this is an interesting one, right? Because it's a profile picture. So will it be decent? It can't. Like, notice my probability, 31, right? It actually got it right, but it's 31% confident because it's a profile and it can't get a full, like all my pictures were straight on. But it still made a good prediction. It's the right prediction, but it's only 31% confident because it didn't have the full face to go against. So let me go pick another one. Oops, going too fast. Let's try this one. It's a little bit better, right? And so now it's in the 80s for Chip. And if I'm in the 80s for Chip, I'm fine about Dale, right? That was my use case. But you could see, like I did all of this. Now I have an app. I literally can let kids, my children, yes, I'm a bit of a geek, build a little mobile app. They can go take pictures and it will tell them who's who. All right. Anyway, 3 of you know how fun that is. But you can build all sorts of things with this technology, right? The ability to tell good produce from bad produce, right? Before it even leaves the warehouse, which we use this technology to do right now. We don't know what good oranges and bad oranges look like, but we do have a model that we can now train on top of to get there. So let me really quickly talk to you in my last few minutes about how this relates to building for natural language. Now, natural language is a user interface. It's very, very simple to do because it's a web service, like I just showed you. You're going to pass in text, and some magic service is going to turn it into speech. You're going to pass in speech, and a magic service is going to turn it into text. But it's important to know, like, that's an algorithm. It was built for you. Let's see. Am I in the right one? No, it's loading. Okay. So in my time at Alexa, what I ended up uncovering was there's 3 major things that you need to know if you're going to build an app for voice. One is that it can't just be voice. Voice only was a 2-year phenomenon when we first launched Alexa, and we did a great job of sharing it with people. I wrote the very first 6 tutorials on Alexa. The very first one was about fact skills. Anyone built a skill for Alexa before? Anyone? No? All right, well, you might today if you want to. But you could build a skill today in about 10 minutes, but back then, it was an engineering effort. You had to actually write software, deploy it to a server. It was a bit complicated. But when building that skill, the very first skill, we had about 20,000 devs build what we call fact skills, like banana facts, yoga facts, dog facts. Anyone called the cat facts, right? It's actually one of our most popular skills on Alexa is random cat facts. The guy makes like 20 grand a month on cat fact. Anyway, I just think it's amazing. It's literally like 800 lines of code. No magic, no AI, no models other than the model that Alexa provides in NLU. Just a bunch, you say something, it mathematically randomizes facts. Crazy. So imagine what you could do, though, if you combine natural language with computer vision. Imagine, and this is available today. Imagine if I could say, right, let's say I'm in my office, I'm going to be like, I could say something like, show me the sales figures. And I would say that to Alexa, but Alexa would launch the URL on my browser and show me the sales figures specific to me. It detects my voice, knows that it's Noelle asking, doesn't do authentication. I'm already authenticated into the system. It just knows that it's Noelle versus one of my peers and can say, oh, you want your sales facts for your region, here they are. And then me, just using my voice, can say, oh, Italy looked like it did pretty good. Can we dive into that? Just like that, supernatural, right? And it goes, absolutely, Noelle, sure. And it renders back a deep dive on the Italy numbers. This is a very business-like use case, but the same is true. I recently wrote a voice application for a hospital, a neonatal intensive care unit. Sad news, my first son was in it's basically called the NICU. It's a emergency room for babies as soon as they're born. And they literally, when you get there, I don't have a good, well, something like this, but they literally hand you, your kid you just had is like in trouble, and they're like, here's a bunch of paperwork. Read through it. It has all the information you need. Let us know if you have questions. I literally was like, in the trash. I got nothing from that. And more importantly, I was kind of irritated that they asked me to find out the dining room location, where's the coffee, why can't I get balloons in my guest room, all of these things in a PDF. So what we did is we created a voice application that enabled all of that. We basically ingested into a pre-built model about 700 pages of PDF documents with questions and answers from the hospital. Now, I, as a patient, could say things like, where's the diner? It would know where I was based on my device location and give me directions. It would also show it up on the screen so I could see where I should go. It would say, oh, by the way, but it's not open now. It opens in 15 minutes. If you'd like, I could call the nurse for you, right? Like, it creates this conversational element where you're not like forced to read through a PDF and find the answer to your questions. But here's what we also did. We added in things like meditation, which I'm an expert at, and we added in affirmations and classical music. They went from a 22.7% satisfaction rating to 84%, I think we're at now. Now, mind you, people will almost never give you 5 stars in a hospital situation where their kids are in trouble. Almost never. I've never seen it happen. Because it's just not a fun time. But to get in the 4s, to get 80% or higher, like, you're doing pretty good. And especially to come from like the 20%, throw your stuff in the trash. Now people were getting what they needed, and they could just say what they needed. So we call it top of mind or top level intense. So when you're creating a voice experience, you should have a voice experience for any piece of software you build today. There's no excuse. Why? Because I have a very tiny little kid, 2 years old. She knows how to grab my phone. She knows how to type in. Now it's harder because I made it 6 digits. But when it was only 4, she could type in my 4 digits, and she could go to an app called YouTube Kids. She knows what it looks like. I actually think my phone's smart enough to know when she's holding it, because when she pulls down the list, it always has YouTube Kids in there. But when I'm at work, it never shows up. So I'm like, what's going on? Anyway, more AI. But she pulls down the list and YouTube Kids is there. But here's what she does, right? She clicks this magic button called the microphone button, and she starts talking, and she will say, bus, and Wheels on the Bus shows up, or Peppa, and Peppa Pig shows up. She knows that with her, she's 2. Eventually, she will be 14 and want to use some apps. She will be 22, she will be 40, and I guarantee you the work we're doing right now to train her to use her voice to do pretty much everything, she's going to expect in software that we right now are responsible for building. So everything we build today should have a voice interface. We say voice is everywhere. Not it will be everywhere, it's gonna be, it's everywhere. Every app should have it. So how do you do that? The very first thing you should do is think about your existing, let's say if you have a web application or a mobile app, the good news about that is you already have users and they're already telling you what they want to do every day. And not a single person, so again, my 4-year-old, for example, Jacob, he will say to me, like he'll use my phone and he will speak to Alexa on my phone to play games with my older children. There's a thing called Simon Says, and basically it allows you to say something really quiet and then Alexa will speak it really loud. So he will say things like, tell Jacob to hit your sister. And then Alexa will be like, Jacob, hit your sister. Bam! Like, what? You're brilliant. How can you even be mad? Like, that's brilliant. So it's hard to be angry at those. You're like, that was really smart. Don't do that, but that was so smart. And he's 4. Anyway, so like there are ways, there's these technologies. Our kids are learning how to use NLU. The only thing NLU can't do, and let me phrase this maybe a little bit differently, it is limited only by our imagination. The tech is there. If I want to do literally anything that I can dream of, I can basically build either by leveraging an existing model or writing my own. The tech is there. So it's literally the limitation of us building fact skills, our limitation that's keeping us from building engaging skills. So what do? We go in, we analyze click trails. Are we done? Yes, okay, this is the last part. So we analyze click trails to provide the ability for us to, so you know what click trails are? Basically like all the activity that's happening on a mobile app or web app. So I know that these are the top 5 things on my app that I want to look at. And then the other side of it is how long does it take someone to get there? So maybe it takes 5 clicks to get to something they go to every day. That is a perfect example of something you'd want to voice enable. What we did a few years ago was routing numbers for banks. I don't know if you guys remember, but it used to be hard to get them. You'd have to like click 5 times through a menu item, ask for 4 things to get it. Today, you say it with 1 command and you've got it. And that was a magical experience for the financial industry. Everyone liked using it, and it launched their voice-enabled products. So think of something that's hard to do, takes a long time to get to in an app or in a mobile app or web app. That's your very first thing, and that's what we're going to actually ideate and create in the workshop today for those of you lucky enough to attend. So I think we were going to take maybe a few questions, yes? So I didn't know if you guys maybe had some questions, and if not, I have more things to talk about, so don't worry. Questions?
Now we'll get to the question part, but just before that,
sure.
I'd like to remind about lightning talks, aforementioned lightning talks, which you can sign up for through our website. Also, there are thousands of hidden codes in this building, which you can use through our website to win coupons for the XCOM shop. We encourage you to take part in this game. So now, if you have any questions, you may raise your hand, and I'll hand you the microphone. Okay.
All right. There's one up there too.
Yeah, according to your observations, researchers, can you tell us? Can you predict in what direction will the AI thing go into? In the next 2 years or 5 years? Or?
Sure. So the question was basically, just so I make sure I understand it, like where do I think AI is going in the next 2 to 5 years? So as opposed to where it's going, we right now have a big problem, which is in data integrity. So in the next 2 years, we're going to have a bit of, and it's already happening now, but it's going to get worse in the next 2 years. We have a big implosion that's going to happen around, like, for example, Google is trying its hardest, but it's very difficult. All of these models were built by people just like us, like software engineers and some machine learning engineers. But the data we used was based on the filter upon which we built them. Does anyone know the main demographic of software engineers and PhDs in tech? Yeah, it kind of looks like this room. It's a little more girl-focused in the middle, so thank you, ladies, for coming. But there's not a whole lot of women. There's not a whole lot of people of color involved, and therefore, the models are really bad at predicting anything for those people. And so over the next 2 years, we're going to be working, and Microsoft is leading this effort with Facebook and Google. Amazon is slowly coming around, but we have to fix our data. Right now, we are on this horrible trajectory of having models that are basically useless because the data itself is flawed. Anyone heard this before? Is this news to you? You should look it up. It's terrible. So there is a book that I'd encourage you, if you're a book reader, it's also an audible format if you like to listen, called Algorithms of Oppression. It was written by a couple of PhD students. But they basically went through the 5 major algorithms in the world provided by 5 leading providers and uncovered that the data is really bad, that it's highly biased. and that we need to fix that bias before we build anything else. That being said, so that'll be a huge effort that's happening now. AI and ethics, we're just starting those conversations, so it'll be a huge focus moving forward. But I just got, do you guys know South by Southwest? So I just got back from South by Southwest. You should look it up. It's a cool conference in the US. But it's a global conference. People come from all over the world. But my session was on autonomous vehicles and the passenger economy. And so similarly, like I wish 5 years ago people listened when I was like, build for voice. Because now 66 million people have a voice device and we're not building cool stuff for it, right? We could have started 5 years ago, but people are just now starting. So we're in the same thing where autonomous vehicles, though scary to some of us, totally happening. They're already available in certain markets, right? What happens when you as an individual have another hour in your car that you're not driving? We call it the 25th hour, right? So what happens with that? So now there's a whole bunch of work in AI, augmented reality, virtual reality, content creation, voice enablement. Like what do we do to enable people to do other stuff in the car other than drive? So that is really like a huge part. So augmented reality, virtual reality, mixed reality, I know I've been saying this for years, but it will happen. But I do see that being pretty big in the autonomous vehicle space. So yeah, science fiction turned fact. I think there was a question way up there, maybe? No? Don't make him run up there if you don't have a question. Raise your hand if you got a question. In
Someone
the front.
has a question?
Yeah,
or-
there's one right here.
Okay.
And then,
Esther.
well, yes, and then my friend.
Hi. I can imagine that there are a lot of applications for ordering, for example, pizza.
Yes.
And when you want to add new skill, new application to public repository or public catalog of this application, how user can choose which one will be used? Because I suppose that it is natural to I want a pizza, and which application will be chosen?
That's a great question. So to restate the question, which application, like when you call Alexa, if there are, for example, I own the Mindfulness Skill, but now after I built that, lots of companies have come out, even more better, like bigger brand names than I have now built mindfulness apps. So there's two things. There is no web application concept like domain squatting where you can grab the name of the app. There's nothing like that. So the way Alexa works very specifically is that it allows you to use whatever name you want. It may compete with other names. The first rule that is used by the engine is to determine who enabled that skill first. So because I have this, mindfulness was on the platform the longest, if they enabled a mindfulness skill, mine would have been the one that they enabled. So now no matter who comes up with a mindfulness skill, they will always get mine first because I was enabled first. If there is no enabled skill, it will choose then from a list of popular skills, meaning the most enabled that month, and bubble up 4 in kind of a search result set, right? So it'll say, you'll say, open mindfulness. Oh, you don't have a mindfulness skill enabled, Alexa would say. Here are 4, which one would you like? But again, you still need to be in that top 4, right? So, and that's why I said you have to pick, there are mechanisms for ideating what feature you choose to enable so that you end up being a top level skill. Now there are only 80,000 skills in the store, but like 20,000 of them are fact skills. So it's pretty easy to do better than that when you're building like pizza ordering apps or whatever. But the NLU, or the natural language engine, goes through this kind of order of enablement. If you've already got one enabled, just go there. If you have nothing enabled, surface a list. And then once you've enabled and selected a skill, it will always go to that one. It'll never present you with another option, even if 500 people build new skills for you. So your job as a developer is going to only get harder as more skills enter the environment. We have billions of apps, right, for iPhone. 2.6 billion apps in the App Store. How do you know which one to get? It's usually viral, community, influencer driven, right? Where somebody's like, that's a cool app, go get it, and you go get it. So the same thing's gonna happen for voice. You're gonna have to create communities and develop kind of an influencer type mentality around your skills. Thank you, good question. There was one on this side.
Hi.
Hi.
Could you say a word about privacy in image processing of Microsoft Web Services,
Yes.
and especially speech processing?
Yes, absolutely. So Good news for you is GDPR happened, which created, we basically have two different types of software components. We call them data processors and data controllers. And basically, data processors use pass-through data, which means the data is always held in an ephemeral storage space, which means it's never persistently stored, which, again, that's part of GDPR's compliance, and that ephemeral storage must disappear within 24 hours, which it does. In cloud, what that means is that there's a piece of hardware, like none of this happens without real hardware being involved. So your request comes in to Alexa or to Cortana or however, your voice is captured. We use your voice against a speech service to turn it into text. The text is then stored because it's not your voice, which is the concern part. The text is stored in order to map it to an intent that calls some business logic that you want. So let's say it's order pizza, right? You say order pizza. Your voice utterance is captured. We use speech to text to transcribe it to text. And then we say, oh, if you see order and pizza together, call this method in this class, if that makes sense to you software developers out there. And then that class calls and then the reverse process happens. But the data itself, and now this is, we actually were in a really good spot because Microsoft has always been kind of very concerned about ethics and privacy. So we didn't have to do very much when GDPR came down in the US. In the US, it's not required unless we deal with European companies. Microsoft put GDPR requirements across all of its technology, whether it ever hits a border. And what that means is that we don't persistently store people's data and utterances. Now, for Alexa, it's a little bit different. They will store your utterances because it's how they make Alexa better. But for everyone in here who has an Alexa or who has used an Alexa, as soon as you create your account on Amazon, you check this box against a EULA or a user agreement that all of you I know read entirely before checking. And in that EULA, it says you are willing, able, interested, excited to give your data to Amazon in order to make better products and create better recommendations for you. And the reality is, which is shocking to me, I sat in a user group. The reality is we actually are willing to sacrifice privacy for convenience. When given a very specific use case of like, hey, we'll make this super easy and super cheap, but we need your data, almost everyone, like 93% of the people asked, said yes. I, of course, was like, are you sure? Do you know what that means? Like, this is why we have to educate the planet on what these data models are doing and how this data is being used. But we are giving that away. So from a privacy perspective, unfortunately, the EULAs are very clear about how people are using data. You know all those cookie things? How many of you are saying no to those? Cookie, like, you know what I mean? Like on a web browser, it pops up a cookie saying, we're going to use your data to make life better for you. How do you know what they're going to do with that data, right? Microsoft's super careful about it, but most of us are clicking that away, like, sure, yeah, sure, okay, it's fine. So great, we answered a question, but it doesn't solve the problem, which is what exactly happens with that data, what model does it feed into? Right now, we're blanket giving that permission away. I think part of your question, over the next 2 to 5 years, there's going to be a bit of an awakening of like the world to like, oh wait, what did that do? How is that being used? And GDPR is part of that, but we also need regulation worldwide, meaning specifically in the US, to enable that as well. But great question. Privacy is always a scary one.
We've run out of time, so
yes.
That was the last question.
Perfect.
Those who asked the question can come to me. I got some prizes for you.
All right.
Yeah. Also,
wish you asked a question now, don't you? I should have said that. That's awesome. Well, thank you guys very much. It's been my honor. Go to Dev Collective online if you guys want to join my community, and I'll see you guys at the workshop. Bye.